They are not started. ಅಲ್ವಾ?
From my guide and my mentor, Dr. Ines Kumar. I hope the voice is audible because we are in the link with the YouTube also. Sir, kindly excuse me.
Oh, yes. It is audible. Very good. Okay.
Thank you. Thank you. So on behalf of Sir MVT Civil Engineering Department, I invite Dr. Ines Kumar, my guide and mentor. Today, the speaker of the day is Advanced Nanomaterials. I hope all the participants, 63 participants have joined. Actually, about 1 or 2 has to join. Just for 2 minutes, sir.
Okay.
Because just for 2 minutes, we'll start off. So today, the program starts like this. We have third session. After third session, we'll be having validatory function, my dear participants. And after the validatory function, the feedback link will be shared at the end of the program. And those who submit the feedback link will be getting the certificate or what or so. And you can give us the valuable inputs of this 2-day program. I hope the morning third session was very impressive. Very good afternoon, participants. I hope you had a good lunch, virtual lunch, the second day program of the fourth session on nanomaterials. So in this view, the fourth session will be delivered by Dr. Ines Kumar. A brief resume. I welcome Dr. Ines Kumar. I'll just read out the resume and later he will deliver the speech. Dr. Ines Kumar graduated in 1985 from Mysore University, master degree in structural engineering, 1988 from Bangalore University, and earned his PhD from Bangalore University 2006 under the guidance of Dr. N. Muniradappa, the chairman and professor of UVC. And later, once he's completed his education, he started working in a consultancy firm to get a clear concept of the what has to be taught. So hence, he joined the Steel Research Foundation 1989 as an engineer and learned the basics so that the teaching lines will be clear. And later, he joined as a lecturer in 1989. And presently, he is working as a professor and head of the department. and is an R&D head for the institution. And he is involved in the research field related to the behavior of composite steel columns and nanomaterials since a decade. As on date, he has completed 32 years of teaching research experience, plus his work for TOS also almost over 30, and he has guided one MSc engineering by research and 3 PhD. I am one of the student of him, and he's a role model for me. So, and presently he's guiding 5 PhD scholars under VQ Belgaum. And to his credit, he has authored 8 books on structural engineering syllabus pertaining to the Bangalore University and VQ Belgaum. And he has also presented more than 4 research papers at world international conferences held at USA, Canada, China, and Australia. He has completed one V2 R&D project of worth of 15 lakhs, working presently as an vision group of government of Karnataka, project worth of 40 lakhs in the area of nanomaterials. So we have a very, very eminent person today, will be quite impressive to all the participants, will be useful. And he's also a board of reviewer of more than 10 international journals, American Science Direct, Journal of Materials USA. He's also a member of National Board of Accreditation, and he has visited a lot of as a peer committee for NBA, and as well as LAC, VQ Belgaum, and he's also a board of examiners for Bangalore University and as well as VTU. And later coming to his awards, it's a very big list of awards he has got. I have given only mean awards what he has got. So in 2011, he got the Mumtaz Ahmad Khan Award for Distinguished Exemplary in Service Community, as well as he was an Education Icon Award for the International Chamber of Service Industry, New Delhi, on 5th Global Education Summit, 5th October 2020. Later, and also he has got an Award of Excellence in Research in 2021, awarded by Novel Research Academy, Puducherry, India. And recently has got an award, Dr. B.K. Ramaya Memorial Award 2022 for his excellent career achievements on 22/1/22. It's a small list, but actually has got a long list. Because of the time limitations, I'm not able to read his lot of awards. It's only in January 2022, recent one. And he has done a patent also publication with an application of a titled method for preparing a novel composition of nano cement mortar by using hollow site, nano clay, and multi-walled carbon nanotubes. Dated 27, because in patent the date is most important. You can refer in the website. It is 27th of 8th of 21. He has patent is being published. And at present, he is guiding about 5 PhDs and about 2 students are under progress for submission. And with this very high profile speaker, I invite you, sir, on behalf of our civil engineering department, as well as Sir M. Wade. We'll be sharing the screen of the PPT presentation.
Thank you very much for very nice introduction.
Thank you, sir. Thank you, sir.
You are my first student, actually.
Yes, sir. Yes, sir.
All the best. Now we will start it.
Yes, sir. I'll share the PPT. Few minutes, sir.
Okay.
Few seconds. Please, sir.
Oh yes, it is visible. Now now I can start, I see.
Yes, sir.
So at the outset, I welcome all the participants. I feel many are in the teaching field, some are in the industries, some may be consultants, some may be in the construction field. I welcome you all, and at the outset, I thank Sir MVIT Institute for agreeing to invite me, mainly because of the HOD, Dr. Ravi Kumar. So now I am going to present the recent advances in nanomaterials. Next slide. Yeah, now I wanted to, whatever we say in all these lectures, many of you have already, you might be a participant, or you might maybe a student, or you may be a contractor or an engineer. whatever we do, we must talk, not simply directly downloading from internet. So what I am going to present is what we have done in our college due to a funded research. As he was telling, it is around 40 lakhs, which we got it through CNR Rao was in the search committee, and it was in 2013, 14, 15, 4 years, 16. So all this work again we never stopped. Due to this work, many have got their PhD and also MSc engineering. So now at the outset, nanomaterial, many of you can get this meaning, you can download, you can understand, but practical aspects I am going to tell you in the next slides. Nano means which we can't see by our naked eyes, all of you know, and the size is so small, it should be through a powerful electron microscope. It is of the order 10 to the power minus 9. Okay. Now the question is, there are so many types are available: single wall carbon nanotubes, nano fly ash, nano titanium, are all very costly also. Whichever is somewhat feasible, I am going to present regarding nanomaterials of single wall, multi wall. Both are carbon nanotubes. Along with that, we have done some research on halloysite nanoclay. Next slide. So here, applications in general before starting. So it has got a very wide application, as you are seeing in this slide. It is coming for even for medical field, energy, manufacturing, medications, even for disease treatments, and also for in all the metallurgical engineering, even in our civil engineering, waste also, even for waste disposal. Some of the methods we use this, even in defense, highway engineering, and also biomedical engineering, industries, sensors, so many things. It has got a very wide application. This is the slide which is indicating the importance of the nanotechnology nowadays. Next slide. In the next slide, same thing in a easier way to remember. Why it is so? Because it is durable, photocatalytic. Durability is the main point here, and pore refinement is one of the very important, and its rheology is so interesting. And about this strength, what strength and all, I will be explaining in the next slide. When you see this, we are talking of nano composites. Composite means it's a mixture, it's a matrix of two different items which are entirely different. One is the reinforced, and the other one is a composite. It's a combination of, here I am showing you polymer interaction zones will be there. We are going to add both what composite material, including either halloysite nanoclay or carbon tubes, which may be single walled or multi walled. This whole thing is called as the nano composites. Nano fillers or nanotubes, nano plates, nano shells. I have taken nanotubes here. Next slide. Next slide, you are going to see the importance and some of the properties. Multi-wall carbon nanotubes, how it looks through the electron microscope view. It is having very good high electrical and thermal, which is very good in tensile strength, very flexible, and also elongation is 18% to failure. Hence, they are highly elastic. That is important. Very important is low coefficient of thermal expansion, and it is having good electron field emitters. And aspect ratio is high. That is one of the advantages also, which you will come to know in next slide. Here, some of the advantages I am telling. Excellently, we can replace it for metallic wires because of the lightweight and very, very small size. That is the advantage. But CNTs performs very well under extreme heat, which has been from the literature review, and it has been also sought over for the research topic nowadays. And there is a significant boost in the economy as investor. Now, very recently, I hope you might have seen in all the Google and this one YouTube that there is a one industry in Jigani. Now it has been recognized internationally, where I went and purchased. There they are manufacturing this nanocarbon tubes. Okay, he was from BMS College of Engineering. Then after MS from US, that person has started the company himself and is a manufacturer. It has gone to global level. These are the applications it shows. A lot of applications what I already have shown you in the previous slides. Next slide, when you come to the next, here, these are all especially very big interest for chemical engineering and internal what is going on. Some of the properties I have written. Formula Al2SiO2 O5 and OH4 it is. Okay, some of the pros and cons you are seeing here, some of the other plus points, some of the minus points. There is a little understanding about the working, and that's why it is under infancy research. Now it is coming to a certain level. Even at Indians of Science, there we have got nano material testing lab worth 450 crore. So here also we thought of establishing in our college 40 lakhs. So slowly 40 lakhs we got. Again we have applied for 60 lakhs. So like that, one day we can't do suddenly. So they have got 400 and odd crores. So we all visited. Then I started the research. So it's a more than 5 to 10 years we have taken. So these are the plus points and minus points to understand the behavior. How far it is helpful to civil engineering. That's what we have done. Next slide will indicate you here what we have done is cement, usually any grade available, 53 grade. Sand we took locally available, just like in any project of your BTech or MTech or this one. Water from usual available in the college laboratory. Carbon nanotubes is the important, and the company is in Jigiri, Nopo they call. It is in the industrial area, and we went and we have ordered and we checked it. Along with the carbon nanotubes, one more material we took for comparison I have taken. That is called halloysite nanoclay. It's a naturally available, they are telling, in New Zealand seashore. That will be processed. First of all, for doing all this, next slide, we want an equipment. First, we have to get the equipment. Then you the material. Equipment cost is around 25 lakhs, and this was imported from UK directly from London. And they are then the manufacturers they give all these things, and it is a different two levels of research. First level we got 20 lakhs. Again, after 2 years of progress, another 20. So without showing the progress, nobody will give you any of the research funds. So many of the audience may be students, may be doing PhD, I feel. Some are interested. So I am telling funds will be in stages. Nobody will give even a rupee without showing we the progress. So first we went to for this particular equipment. What is the use is the question. This is not available here. They are thinking it is imported actually. Suppose you keep a piece of chalk we can do for compression test, and we can plot load versus deflection curve for a piece of chalk which is highly brittle. Then we were example 2 3 sheets of paper you can punch no in punching machine. Take the punching machine, keep it on this equipment and compress it. You will get the small load required to punch the 3 4 sheets of paper. So much of specifications and so delicate. So see these features 1 kilonewton to 25 kilonewtons, and load cells also are very important. And remaining software will come along with the equipment, and they will come and give the demo. And through the Bombay, they will import it. There is an import export agency, and we have to get the import export license to the institution first. This is also important. Any institution they will ask in NBA, have you got import export license? Is it meaning of that first staff members they should know. Nowadays these are the common things what I am observing. If without import export license you cannot purchase any of the equipment from abroad. If you purchase from abroad, oh, it is very helpful for understanding also. Instead of going, we all cannot go abroad, you get the things from abroad here. This is the idea, and they were happy and they sanctioned the amount. Next slide. It's a highly controlled machine. Some of the tests we did, and there is a one what is known as sonication. Sonication means just like a mixer. Either you mix it, or without mixing you simply put it in the mixture. So this is non-sonicated and sonicated specimens we did. Next slide you will come to know. This is the methodology preparation of the mold, dry mix, how to add it. So some 4%, 6%, 8%, as you do for all BE projects, MTech projects, same type. The question is material is different, but this is how we do any research. Start starting from minimum percentage, go on increasing till it reaches some optimum. You will come to know the usual process and how to mix it either in dry state, how to do it. All these things we have followed it. And the specimen size is so small, 40 by 20 mm are the specimen size for split tensile test. Compression testing, see 40 by 40 by 20 millimeters. And flexure also we did. That's what in two stages, which took 6 years. 2 plus 2 plus 1 year, so like that. It's a long process. After that, after getting the flexure equipments with the size, it's not a beam, it's a prism. 40 by 20 by 100 cross section. Next slide. All these three tests with different mixing proportions, cement and sand in the ratio 1:2, water cement ratio using the nanomaterials. Question is placing the wet mix, that was dry mix. This is wet mix, 3 layers, and we have to compact it like any other experiment, and end extraction during curing. Now, number of days. There is no coding here. There is no IS code here. It is not coded yet. So that's why this is called a new field. 3 days, 7 days, 14, 28. We can go on increasing this up to 265 days, 360 days, like that. So there is no any specification yet to be fixed after conducting experiments in the country. This is what is the idea. It is at the stage of infancy. This is how we have done. Next slide, you will come to know air drying, then experimental testing. I explained you just below. Mechanical properties, at what stage it cracks, stress strain relationship, auto plotting, and you find the stiffness, load versus deflection plot, and if you take the ratio, P is equal to K delta. So K is load by deflection. So the straight line portion, from the graph of time, you can this, and E also we can fix, no, stress versus strain from that Young's modulus. So next step will be in the next slide. Some of the how we did the compressive strength, how you started, I will explain next. See, the sample preparation is a big this one challenge, and we are not getting the molds directly because the specimen size is too less, very small, no. So how to mix? Then we have to take a plastic sheet of this one and get it punched. Then this will become the mold by ourselves. We have to do this, and there is no anything available in the market. We have to get the sheet, and to our size of requirement, we have to make the molds, and then we have to go for curing, not in a big water tank. It is only in a small tray, plastic tray, and small cubes. It may be cubes, and if it is a Swiss tensile strength, it may be cylinders. Okay. Next slide. During the testing, we have to take a lot of precautions. Even for that slide is missing here. Even we have to wear the mask and gloves, and same as what we have seen in the case of corona, the whole kit. No, almost same type we have to do, because if you inhale carbon nanotubes, then I feel you will get the cancer. It may be lung cancer, or it may be blood cancer, something very serious. That's why without precautions we can't do all this. That slide is missing here. I am showing you only hand gloves. Everything we have to include in the special made spectacles which they will supply. All precautions we have to do this. Okay, this just I am showing you how to test this during testing, mounting, and how it cracked. Next slide. Some of the results is autoplat. That is very interesting. The software what they supply, they will explain when they supply, and we learn slowly. All our students, BE students, MTech, PhD, all the students at once. So that slowly all will be released with the different degrees. That's my idea. So it took 10 years. So these are the graphs showing this. All this you can understand. Load was 3 day, 7 day, like that. Cracking load plots. These are all individual plots for different number of days to analyze. 3, 7, 14, and 28 days after that we tested and plots as usual. Next slide you will come to know all these plots for different. I am showing you for different proportions. Next slide. All these results, every variation percentages I am showing you. Next, so that you will have an idea. At 28-day testing, variation in cracking load and compressive strength comparison is very important. This is 4%, 34.36 at 10% by weight. 1113. This is for multi-wall carbon nanotubes. What is this? 4, 6, 8, 10 variation. Here, this is for halloysite nanoclay. 4, 6, 8, 10. Halloysite nanoclay looks like a white powder. That's all to look at. Whereas this looks like a soil, some sort of very small ash. But actually speaking, when you go through the microscopes, you will come to know it is a multi-wall carbon nanotubes. Whereas here it's a hallocyte. This all of you may be knowing, even in soil mechanics or geotechnical engineering, we are using these nowadays. So this is how we did the percentage variation for two types of materials, and we compared it at the 28 days. Next slide. Variation of Young's modulus we compare. Next, better to do split tensile strength also. You know the meaning. Split tensile strength, where we keep the specimen longitudinally, and this is how this is called indirect tensile test. This is what I showed already. Same type, casting and curing for split tensile. We did. Next, same type. Next, these are the results for split tensile strength. Next slide. All these results, because all these went for BTech project, MTech project, and PhD projects. So we did a lot of graphs. I am showing you some of the important for your interest. Next, these are the results of your split tensile strength. Similarly, suppose how we did for 28-day testing also, the cracking load and also the strengths we compared, same type, HNC versus multi-wall carbon nanotube, which is better. That was the point. Which is costlier, which is somewhat better. We want good strength, but we don't want to spend money. That's the problem. So finally, which is economical, it's a big challenge. We did with 2-3 materials and we tested it. All are nanomaterials. Next slide. Variation in K, stiffness we did for all these comparisons. Next slide. To find Young's modulus, to find the stiffness, to find the cracking length, all this I am explaining you in a diagrammatic, just it's a symbolic. Now, we also thought of doing bending test. Flexure strength testing is also important, but it's not a beam, it's a prism, small prisms. So next slide. During the flexure, see these are the looking like a slots. This is a mold. This is the size 100 by, so small. All these molds we have to prepare ourselves, not available elsewhere. Do it by yourself. You have to do the cutting, then you have to do this how it looks. It is not beam, I am telling. And how to mix it, then how to get the what casting. Then we went for curing. Next, see here, this is your load cell, and this is what I am telling. It's a B, it's a prism, single point loading. This what we did in do in strength of materials lab, like that. See how it is cracking. This is a very important site, cracking, and this is how it cracks, where it cracks and all. For that we have to study what is known as fracture mechanics. Fracture mechanics also a subject. I feel nowadays many may not. It is a very important topic for research. Fracture mechanics, there how the fracture start, what type of failure it occurs, all that we study. Next slide. Next slide, if you see results of this flexure testing, I have shown you. It is of very interest for the research people. Many may not be interested, but to prove that real work is done, I am showing you all the graphs. Every graph will take minimum 10 minutes or 1 hour to understand. Next slide. These are the results. Next. These are the results. Now you see, for the same type we did for flexure, I explained, same HNC versus multi-wall carbon nanotubes and hallocyte nanotube comparison. All the results we are writing here, so that you will have a pakka idea of what is happening to flexure, what is happening to tensile strength, what is happening to compressive strength. Next slide. All the variations, how much we got. Young's modulus variations for all the 4 into 4, 16, into so many trials. There's so many experiments we did. Next slide. Next slide. Experimental testing on all these were non-sonicated. Now you go for sonicated, means with a mixer like called as a sonicator. Next slide. There is an equipment, and this sonication is just like a mixer in your kitchen. You put it and you can switch on this switch, and it takes around 55,000 rupees, 70,000 rupees, 1 lakh rupees, and it is a time control. It's like a mixer. It's a big drum where it will rotate, just like your washing machine. It's a small, this one sonication, using ultrasonication. So many types are there, and finally we procured this also through the funds. So this is called sonicated specimen. You instead of hand sonication, we went for sonicated with a proper time limit, half an hour, 1 hour, 45 minutes, 1.5 hours after sonicating, we conducted the experiment. This is what I explained. There are two types, probe sonicator and bath sonicator. We have done with bath sonicator. Next one. These are the available in the market, probe sonicator and bath sonicator. This is a probe sonicator, how it looks. Next slide. Next slide, if you see, this is what I have purchased in our lab, bath sonicator. What we felt, okay, somewhat cheap and within our budget of our research funds. So this is how it looks, and all these lids, and we poured this and all the procedure, more than 2 weeks we had to understand first. That's what I'm telling. One student cannot do it. First, one PhD student, under him 3 4 MTech students, and each MTech student under minimum 3 or 4 BE students. It's a tree chain. It's a combined effort of all these. Then only I cannot do, or one cannot do. Guide should guide in a chain way. Understood? PhD, he will help MTech. MTech students will help BE students. This is how I have planned, I have done. Okay, what is done, I am explaining. Next slide. This is what how it looks. Next slide. What's on indicator? Explanation is there. Next. Methodology. That's what. How to prepare the mold, prepare the mix. Sonication. 10 minutes, 20 minutes, 30 minutes. You can go for even half an hour, 45 minutes, and also for 1 hour, and for 1.5 hours. So this is how we did sonication. And we will add the nanomaterials, 4%, 6%, 8%, and 10%. Okay, next slide. This is what 1:2. For sonicated specimen, same type what I have explained. 3 layers of compaction, 25 times with the glass rod, number of days, same type, with sonication, without sonication, like that. Next slide. Air drying we did. Next we went for testing of 3 items. Always 3 we took. One is compression, another flexure and tension, flexure, compression. We have to make the surface clean, minimum 5 minutes, air drying. These are all the procedure as per the journals. More than 200, 500, 300 journals we were referred. Then we have to plan it. Not suddenly we can't do. With all pakka journal references and online journals, offline journals, hard copies, going to IIT, going to Institute of Science, all that we have to do it. I have done it with my students. Next slide. Sonication process I have explained you. Bath through 1/4 water with nanomaterials in a beaker at room temperature. This is what 10 minutes, 20 minutes, 30 minutes. Water is added to dry mix. This is the process of this, how it looks, how it is going on. Sonication. Next slide. So this is what before sonication, after 20 minutes, how it looks. After 10 minutes, sonication is a mixing. That's all. Just to take a stir it, but we can't do it in hand. No. So this first of all, this is we have to take a lot of precautions. So we took the sonicator equipment, bath sonicator. I can't do it by hand. That's why we are doing all this. Examples: half an hour, 15 minutes, like that. Next one. Next slide, if you see. Compression testing, I explained already, same type. Next, all the results of so many, more than 5 6 years. Okay, next slide. All this of interest for research purpose. Next slide. All the results finally was consolidated either by pie chart, pie diagram, or by bar charts. Next slide. See here, 28-day testing variation in cracking load, how much percentage for what percentage of addition of the nanomaterial. 10%, 10%, 4%. See what is going on for S10, S20, S30. Here also same type. So comparison, no, we have to have a common platform. And for the two materials, it's a long process. We did. Next step. Next slide. Variation of K, variation of E. All this I am showing you one by one by one. Next. Variation of stiffness. Next slide. Next slide, if you see, it is Young's modulus. Same, you observe all. There are 3 items, and we are doing for sonicated and non-sonicated. Materials are of 2 types. That's all I did. Split tensile testing. Last one. Here also I explained with sonication. It looks same, but it is a different material and different specimen. Okay, next slide. Next one, results of this cracking load in newtons versus what? Three types. One is single wall, another multi wall, and one is halloysite nanoclay. Three materials, and one is nominal. So all these comparisons we have done for 28 days testing. Okay, all these were done by students under the my supervision. That's very important. Next slide, if you see, yeah, this is what same story for split tensile strength, same type. First I told about compression, next I told about what? Tension. Correct. Now I am talking the same thing for HNCs and multi-wall carbon nanotubes. Next slide. If you go to the next slide, how the K is varying. Stiffness, load versus deflection plots. We took the straight line portion and we calculated it through the graphs. Next slide. Young's modulus. Next slide. Different values. Everything is different values, but the items are under the same headings. Next slide. Flexure testing. That's what I explained. Next. For sonication. Next slide. All this you can go fast. Same type for different items, different mixers. Okay. In which is done in our R&D lab. Next slide is the probe. These are the graphs already. Same type, but the values are different for different items. So more than 300 graphs are here. Just you can go through. Just I am showing you how much is the work that we have done, so that you can also continue this type of work. You will get lot of just one outputs are very good here. Next slide. Yes, next you can go on moves. Yeah, this is what next. All the results, though it is looking same, the results are different completely. Material characterization. Next slide. That is also scanning. That's what I am telling. SEM is one of the microscope, scanning electron microscope. Using that we have to analyze the output. Next slide. This is what is done. Sample, how to go for the scanning, just like in medical imaging, medical field. Next slide. This is how it looks after. We are not having scanning electron microscope in our college or many colleges. It is very costly in crores. So it is in, now they have got in Jyoti Engineering College, it seems, and they have got in Indians of Science, Bangalore University, 2-3 labs. So there we have to go and give them, get it done. So the process, then we will come get this. This is like our X-ray, just like heart or whatever. No, scanning of our lungs or X-ray. Same, it is looking like Maggie. And what we have done sonicated, non-sonicated specimens, see how it is looking, how it is clogged, and lot of data. Multi-wall, this is halloysite nanoclay. Scan reports. Next slide. All this we have to understand and we have to learn. A lot of learning is there here in materials engineering, material science. I went to Indians of Science. There is a division, no, metallurgy. There we have to go and request them, and they have helped it. Center of Incubation Research, and this was also very important. From there also I got all these results. CIRC, CIIRC. Okay, next slide. Images are all. This is for halloysite nanoclay images, sonicated, non-sonicated, sonicated, left and right. A lot of difference which we can't understand in one day. So it is a completely, we have to talk with a chemical engineer, metallurgical engineer, correct, metallurgical science, no, those people, and we have to ask with a lot of SEM images. We have to first understand, then we should go for our specimen. So this is what we did. For this took 6 months actually to understand. Next slide. EDX recall, energy dispersive X-ray spectroscopy images also we have taken. Next, some of the samples are shown. And what is the use of this is elements analysis. This is O, Na, Al, aluminum, silica, calcium of different, see how much weight you get, atomic percentage you get. Totally will be 100, but how much for O, how much, 2.42, 4, all this you will get the data, all the results output for non-sonicated, sonicated, how the graphs you see here, how it is shot up. This is very important. This is a very big, very important output. We have to understand the subject. Interested only we can do this. With lot of interest, if you do, you will understand this itself. Very important. Atomic way percentages and what are the elements present. This is very important using RDX images. EDX. Next slide. Yeah, this is what for HNCs and for this. XRD means X-ray diffraction analysis. Next. Here, see this is how we get for CNTs, sonicated, X-ray analysis. And you will, that's what I am explaining you, x-axis versus y-axis is almost visible. See how much percentage and how much is the, which element is creating the problem, which element should be more in quantity. That is what we wanted, which we have done it. Next. Understanding the elemental analysis, this is using atomic weights. Next one, X-ray, sonicated, non-sonicated, HNC, multi-wall and single wall. Next slide. Virtual. Next comes how to model this after so much of work of experiment, how to find out the post break length of nanomaterials using all these images, and we are using a software known as image J integral software. This is a very advanced technique. Next slide. Next slide, you see here. This is a Java based image processing software where we can display all this. You can see now. So this is a very new field. We have to understand. Then we have to work. Geometric transformations such as scaling, rotation, all this we can do. Next slide. Crack length measurement, which I was highly interested and I informed student, and they did all this. Two PhD students. We are about to submit this thesis. Next slide. Crack length and what are the observations? Non-sonicated, sonicated, crack length for non-sonicated. What is better? Whether which is better? Whether sonication is better or non-sonicated? Final conclusions we have to draw. So average crack width and also in mu this is with the units. Next slide. These are the observations. Next. See nanomaterial size measurement. See here. Very, this is how, on what date we did, how much is the scale, nanometers, micro. See, these are the measurement between the two cracks. All this we did. Next slide. How to validate it, all your results. There is a software we have to search, and finally we came across Digimat software. It's a version 2021, lost 2 years back, lost 2 years, and 21 and 0.4. That's the version. Same like ANSYS or NISA. Correct, or Avacus. This is the software we are using for modeling this to validate. Next slide. This is about this software. You can go through some of the tools, software, how to do it, modeling, all this. Next slide. Digimat we call. Why we have selected this? Because it's a highly non-linear and highly minute. All this, so many advances we can handle with this. Non-linear is very important, non-homogeneity. So all this we can handle with this. Next slide. After this, I am explaining you the modeling. How it works, Digimat software, how it works, input, homogenization, auto processing, and output. This is what the black box, all this we are explaining here. General workflow, how it works. Next slide. So what are the, before doing any modeling, we have to go for assumptions. Material is two-phase material, one is matrix, another is nanomaterial. All the constituents in the composite are, it's an assumption. It may be plastic or elastoplastic. We are assuming yes, an elastic. Bonding, very important, between nanomaterial and matrix is perfect. This is the assumption. There exists no voids in the matrix, assumption. Nanomaterials do not undergo agglomeration, assumption it is. Spacing between the nanomaterial in the matrix is non-uniform. Nanomaterials used for modeling are straight in nature, which may not be, because it's a new field, no? So using some of these assumptions as per the journals of ASCE, not usual journals, which is from American Institute, all they are doing in US, many of the universities. So based on those studies, and we thought so many of work, so that next people can continue our work. That is our idea of focusing here. Next slide. Then very important is representative volume element we take. I feel many have many in MTech, finite element methods, and we are having a lot of different elemental analysis. In this case, we have to go for volume element method. This is RVE. It's a short form. This is how it is modeling using the software in a micro scale. We are I am explaining here because there will be fibers, voids, grains, tubes. Because it's a single wall tube or multi-wall. How to model this? This is how we do for equivalent homogeneity medium was created from a heterogeneous medium using a modeling known as RVE method. It's a short form for volume element method, right? Next, in the next slide, these are the steps which I need not read every step due to time constraint. I am giving the that all these things you can go through slowly, and any doubts you can contact me also. And it will be with the organizers. You can meet Dr. Ravi Kumar. We will. I am going to leave the slides with him. All of you can go through slowly and go for higher research with funds. I'm telling you, you can't expect any college to give you funds for so many lakhs and crores. We have to get the funds. Using the funds, they have to improve our laboratory. That's what the idea. Next, you can go through the steps. These are the things. Next slide. Steps, modeling steps. So one by one, like it's like CAD modeling. Next, how it is added. See how we meshing. These are the individual RVE model we call meshed model with finite element analysis. See, this is the modeling with mesh. This is what plotting, post processing. All this many may be knowing in your finite element method. Next, software steps, how we get the results, sonication time, how much stress values in MPEs, okay, megapascals, MPa, computed stress, deviation, experimental values versus computational values, how much it is deviating for compression, Young's modulus, compressive strength, for HNCs and CNTs. All this combined, just I am showing you. Each is a big important graph. All I am showing you in one slide. Next, same type for different materials, and average deviation for carbon nanotubes, compression, Young's modulus. See, 12.81, 11.9, 14, 15. Here, 11.8, 12, 11, 10. Some ranges you get, no? Minima, maxima of the variation for 4% addition, 10% addition. These are the color codes. Next, same thing for HNCs. One is for CNT, another is for halloysite nanoclay, compression and Young's modulus. Next slide. This is what all this each test I am showing you: flexure, split tensile, and finding the strength characteristics nanotube using the Digimax. Next, different versions. It's a very modern new version, and here very important is theta and phi. It's a orientation of the nanomaterials. When you use the sonication, or when you mix it with freehand, what angle it will fall down, we don't know. We can't align it, is it not? So 64 degrees, 134 degrees, for particular to avoid the fracture continuation. Lot of story is going into this. Lot of knowledge is required. We have to understand the prerequisite subject is fracture mechanics. So this is what in the software also it is taking these two values from 1990, 64, 134. These are the standards for CM plus CNT, cement mortar with halloysite carbon nanotubes, halloysite nanoclay. That's what non-sonicated, sonicated, average nanomaterial at angles. At what angles? 64 degree, 134 degrees. It's a very good this one. So all these new items we have included. Next slide. What is this means? It's a field homogenization. It's a very good technique to replace the material properties of a heterogeneous media into an equivalent homogeneous media, which is very important. No, heterogeneous to homogeneity. How to convert? Which software? What type of modeling? What are the properties? All this I have mentioned here, and we have to learn the modeling techniques, which is very complex. We have to understand this complex. Already software is done, we have to understand and we have to use it for our field. That's all. Next, failure. Progressive failure theory is adopted. Failure will not stop suddenly. It will be slowly. For one day, it will collapse. No, progressive analysis steps I have given. This is how it is happening in 3D failure criteria. Next slide. Models, just for this also I am showing you RVE, that's what volume model for different dispersion angles, inclined at 64-degree, inclined at 115-degree, theta and phi values. What are the outputs? That's what I am trying here. Next, modeling techniques, steps used for with particular instantaneous damage law with a minimum, okay, instantaneous damage. This is a procedure. That's what we are using this. It's a continuation of finite analysis for nanomaterials. Next step, next slide. Average deviation output, all the results for multi-wall and halloysite nanoclay. Result comparison of stress, Young's modulus, stress, Young's modulus. Similarly, stiffness and this one. Next slide. See, same type for split tensile strength, stress and Young's modulus values for two types of nanomaterials. Next slide. Average deviation I am showing you, flexural testing. Next. What are the final conclusions of so many experiments? Just I am putting in the slides. Next. Finally, there is an increase in the cracking load and compressive strength also varies based upon the age. The stiffness and elastic properties of the specimen is also higher. For example, in multi-wall and HNC comparison. 28-day testing, these are all the stiffness is highest for 4% weight, samples at 195, 4% for HNC. Comparison of all this I am giving you. Conclusions. Next. This is for compression testing. So many important conclusions only I am showing you, which is very helpful for our future research. Next. Conclusions from split tensile, conclusions from compression, conclusions from all the three tests I have written. These are the conclusions. I won't read everything. I am not this one. Just you go through. Any doubts you can call back. Next slide. So many some good conclusions we got. So that I am writing. Next. Flexure testing conclusions. After 28-day test, what is happening? These are the important I am telling. HNC performs better than, this is what I want in a tiny margin way. Halloysite nanoclay is better than multi-wall carbon nanotube because, and also the cost also I am happy. HNC is cheaper than MW. These are the for non-sonicated. Now sonicated conclusions. Next slide. Conclusions from sonication, what happens? So the surface, water floats on the surface while the water remains crystal clear. But HNC starts dispersing as soon as it is added. So some of the advantages of multi-wall, disadvantages of HNC. And using this finally, what is happening? I am explaining. Next slide. After 28 days testing, these are the conclusions. All these are exact what we obtained during the experiment, not for presenting for today conference. This is for research which has fetched so many students highest degree, correct, even PhDs. So we have to do like this to get the degree plus to help the public finally how to avoid the crack or how to limit the crack propagation using nanomaterial. Is it possible? That's what is the final idea, is to it should come to public domain. So all these conclusions were very important. Next slide. So many conclusions you can go through. Next slide. Yeah, all these conclusions, 50 to 100 conclusions, or even including those atomic I told, no, all this from SEM, EDX and XRD. So many conclusions. I can't read all because of the time constraint. You can go through. Conclusions from modeling, software conclusions. Important conclusion. In case of compression testing, computed stress values deviate from experimental value by what percentage? This is interest, no? 10 to 12%. This is 11 to 15%. In case of split tensile strength, how much is the percentage variation? Like that, for each test, what is the percentage of variation? We have ideally what about the error? That also is given, which is not more than 10%, which is okay in modeling. Modeling error versus experimental results. Okay, next slide. From aligned nanomaterials, actually, this is what with your 68-degree, 131-degree, those things. Also, I am explaining. Next slide. Very last one. This is what we did will be. Who is telling this is good work? So it should be patented. That's what I already he has told that I got the patent. I means myself with my students. See, Ghazala Anjum, she is a PhD student along with Chetan Kumar, who is in the Anand Sagar College of Engineering. Both of them are about to submit their thesis, and this is the patented work, what I am telling. And this is the last slide, which is explaining you. First point, are you understanding? The point is the proof is this will be this takes minimum 3-4 years to get a patent. First is it will be published in the journal of the patent from Madras or from Delhi, and here you see the date and all this you can see go through, and this synopsis. This is one of the very important publication. Next slide. Proof that what we did is good work. Second proof that who will say we have done a good work, it should be published in a good journal. These are the types of the papers and these are the journals. One is from America, US journal. Second one is also, see, all these journals which should be indexed nowadays. Which journal is good? Scoopers journal. Second one is UGC care list approved journal. Third one is you see it is an online journal which should be approved with the what standard, simply not in all journals. So this is it's a approved good journal. How do you say? Scopus index is there. Okay, UGC have approved. Like that we have done. If not, all will publish in within half an hour, 1 hour, 2 days. Not like that. Some journals we took 3.5 years. Myself, I feel Ravi Kumar and my paper 3.5 years it took, and Dr. Muthu was our mentor. And this is what I am telling. Not 1 day, 2 day, 3 day journal. This is 3 years journal. It took 3 years. Some journals took 6 months, 1 year for publishing. So this is a proof that the work is accepted. Not in only in Bangalore or this one world over. These are the first is we did the review papers, then we went to the experimental analysis. Everything is okay. We after they approve, the people who are in the board of reviewers should be standard. That's what I am telling. Now nowadays I am saying 1 day, 2 day, 3 day. Just you send today, tomorrow you get approval. That journal will not be accepted by anybody. You lose your cost of this one. So this is free of cost. So many journals. I mean Ravi Kumar, what he has done, excellent, and we never paid even a rupee. So this is how the indication. One is in US, another we did in Scooper Journal. Next slide. Proof of publications, and not only that, how many conferences we went in person because of those no pandemic. We did. I asked my students all these important conferences they have presented, conference presentations, publications, patent. This is what I feel okay for accepting our results. Next slide. So at the at last, I should we can't do any work without money, and we are very happy. We are very grateful also to KF. This one KFIST means Karnataka. There are level 1, level 2 programs for research, and they have given level 2 for 40 lakhs. There is one more program of 60 lakhs. So they are giving a very good fund. Only we have to apply. 160 lakhs, 10, 40 lakhs projects, more than 20 people will get 20 lakhs. Like that. This is what I am telling. So all the audience, those who are hearing, shall also try to get the funds from Karnataka government of Karnataka. ITBT department also is helping, and this is very important fund. So we are highly grateful to them. Okay, so these are the references we did, more than 100 or 200, and because of that we got the patent and publications. All these some of the references. Okay, thank you very much. Any questions? You can. Thank you.
Any question from the audience? It was a very informative sentence. I am this product, the first product. I really salute him.
Thank you.
He's a very mentor and guider. Any questions? Any questions for the audience? I hope he has gone from macro level to nano level. So in this regard, I think, any questions? Okay. Sir? Sir?
Yes, sir. Yes.
On behalf of management, Sir MVT and Civil Department, I thank Dr. N.S. Kumar, guest speaker of this session, for a very informative on nanotechnology, which is emerging technology course in the BTU technology course syllabus. And this technology is very, very much important and very useful for our research and has to be developed. And most of the countries have adopted, and only thing, unfortunately, we have to adapt it with your guidance, sir.
Yeah. Thank
It's
you.
very important to youngsters to take a note of his presentation to macro level to nano level, and we youngsters we take it in notes, and also youngsters are there in this. All Karnataka as well as Coimbatore also participants are there. From Tamil Nadu, Kerala also the participants are there. And your presentation was very good for our research activities in future, and as it helps in many ways of controlling cost and structures. In this regard, we are extremely thankful to you, your request. We request you your support and guidance in future course of activities for all our participants. And sir, a very, very
Thank you.
thank you, sir. And we'll be starting the validity function. Will you be a part of validity function, sir, please?
Okay. Thank you. Thank you. Thank you.
Can you join for the validity function, sir?
Okay. I will try because there's a meeting now in our college. I will try. Anyway, all the best. Okay.
Yes.
Thank you. All the best. It was nice.
Thanks a lot, sir. Thanks a lot.
Thank you. Thank you.
Thank you, sir.
Thank you.
Within 2 minutes, we'll be starting the validity function. Wait for 4 or 5 minutes. We'll start the validity function. Anita, madam, you can put the validity slide, please, madam. Yes. We'll start the validity function shortly. Just 2 minutes. If possible, have a chocolate break or a coffee break for 2 minutes. I hope it is online. So after the meeting, you have to. So coming to this, shall we start? One of the participants, the voice is audible. One of the participants, kindly answer.
Yes, sir, audible.
Audible. Okay. Can we have the photo session now? Switch on your video, everyone, please. Switch on your video, everyone. Switch on your video, please. Nice to see everyone. Sridhar, Sharda, if possible, kindly on your videos. We'll take a snapshot for our remembrance. I hope you all enjoyed the program. Okay. Madam, I can, I think, any more photos? Any more can, this clip is being taken, Anita madam? This clip is being taken?
Yes, sir, it's been taken.
Okay. Anyone can please stop the videos of viewers, and other people please join for the video, photo. Any? Okay. Now, Anita madam, can you share that valedictory PPT, please?
Yes, sir, sure.
Very good afternoon once again for this varied function of faculty development program. Just a summary of what we did for this 2 days activity. On the opening day, 5th January, we started with a virtual lamp lighting ceremony, followed by the first technical session was on topic of roles on materials in modern construction practices, and the guest speaker was Dr. Prabha Mohandas from NIT Trichy. The second session was on topic virtual construction application of building information modeling, being by Dr. S.P. Srinivas. On the second day, we started with a technical session from our alma mater, our alumni, Anupama, who is now working in sustainability. She spoke on sustainability, challenges, opportunities, natural resources, carbon trading, and its importance. And finally, we ended up with the fourth session, technical session on advances in nanomaterials. And the guest speaker was Dr. N.S. Kumar. I hope he explains from macro level to the nano level for this faculty development program. And this faculty development program, we have received about 400 registrations. As we had a limitation in our Google Meet, we have 103 attending Google Meet and remaining in YouTube. Next slide, please. And just as a summary before the vote of thanks and the feedback, I want to share our department. We started in 1986 and the initial intake of 60 students. We offer UG courses. Usually we taught based on this online what we had. We teach with the theory and practice, keeping the continuously current scenarios in this field. In addition to teaching and learning courses, the faculty is also engaged in guiding the projects. And recently, our college has been recognized R&D Center to guide for MS as well as PhD. And before the vote of thanks, I want a feedback. You can on your video as well as you can speak for what. Yes, anyone wants to give the feedback, please? I hope the third session was very informative. Everyone was jovial and answering the questions in the third session. Anyone feedback, please? You can on your video, and we are. Please tell them your valuable feedback for our next programs.
Sir, the session was very nice, sir. I am Dr. Seshadri.
Yes, sir.
Hello.
Yes, sir. Yes, sir. It's audible, sir. Dr. Sheshadri, it's
I am
audible,
Dr.
sir.
Seshadri, working professor in ATM college.
ATM college. Place, sir.
And, I did my research in structural engineering. And in spite of doing research also, I learned so many analysis, that is how material development. I found it was so research. So thank Dr. N. Kumar for
Yes,
his and morning session also it was very nice. Anupama, she has shown us ways of that is environmental pollution or sustainability and everything. She has very nicely. And yesterday talks also very nice, sir. In this way, I want to thank the organizers and you for conducting the session, sir. Thank you, sir.
thank you, sir, for your valuable feedback, sir. Dr. Shishali, sir. We'll be in touch with you, sir, for
Yes, sir.
any more feedback, please. One or two participants can unmute yourself. Now I request Professor K.V. Prasad to deliver the vote of thanks.
Before I would like to start, I want to say Namaskarams and good afternoon to my guide, Professor Dr. N.S. Kumar, if he is there in this audience. Good afternoon to one and all. It gives me immense pleasure in presenting the vote of thanks in this two-day faculty development program on new generation construction materials and technologies, organized by the Department of Civil Engineering, Sir MVIT Bangalore. First of all, I would like to thank our management, Sri Krishnadevara Educational Trust, for sponsoring this program. I wholeheartedly thank our beloved principal, Professor Rakesh S.G., who guided us and mentored us in the successful conduction of this program. I take this opportunity to thank all the eminent resource persons, Dr. N.S. Kumar, Mrs. Prithvi, and Miss Anupama V, and Mr. Srinivas Padala for sharing their valuable experience and research with our participants in these 2 days. I would also like to thank our HOD, Dr. Ravikumar H, for working tirelessly for the successful conduction of this program. Special thanks to Mrs. Anita J, Mrs. Pradeepa S, Mrs. Tamil Selvi N, and Mrs. Ramya N, the main coordinators of this program, who has worked untiringly for the successful conduction of this program. I take this opportunity to thank Dr. Jagadish Kumar, Associate Professor, Department of Biotech and Chairman, Media Publicity of Sir MVIT, for providing the YouTube link to live telecast this program. I also want to thank our backbone, our other fellow faculty members, Dr. Shivana S, Mrs. Vaishnavi DR, Mrs. Bhavya S, Mrs. Subhadra GD, and Mr. Sriram Mustapure for their help in the successful conduction of this program. I wholeheartedly thank all the participants who have registered in huge numbers, who has responded to our program. Nearly we got 400 registrations. Really, we want to thank each one of you and your supporting institutions who all have registered and participated in this 2-day event. We thank all of you who have made this program a grand success. Last but not the least, I thank all who directly or indirectly helped us in the successful conduction of this program. Thank you one and all. Before we wind up, can all the participants in batch wise, can you keep your cameras open so that we can take group photo of the participants, please?
Anyone has missed the group photo can on your videos, or you want just one more? Now also I thank Prasad for giving the vote of thanks. And also I thank all the participants here. Anyone has missed out, please on your videos. Mr. Y. Rajesh, Srinidhi, Sharda, Tirumala, Vijay Shankar, Shivana sir, Y. Rajesh, can you on your video, please? Vijay Shankar. Okay, thank you. The next set, please. Next set, yes, sir. Shekhar sir has come.
I already talked with you, sir.
Yes, sir. Thank you, sir. Thank you, sir.
And,
Thanks a lot. Thanks a lot. Okay, thank you, sir. Other participants can on your videos. We'll be continuing. I hope the feedback link will be
More
shared.
than 3 days are there.
Yes, sir.
If the session is more than 3 days,
More than 3 days.
they join, and the next day.
The voice is breaking. Sir.
This is my suggestion, sir.
You want for 3 days program?
Usually, only 2 days or 3 days, not more than that. Because
Yes, sir. Yes,
if
sir.
5 days are there means, so many of the faculty members, they forget it, or they may involve in other works. So like that, the people will discontinue the sessions. Now I don't think that nobody is discontinued, because to only 2 days, that to 1.5 hour, it is very easy and very compatible also for all the faculty members, those who are attending. Kindly take it in consideration.
Yes, sir. Yes, sir. Thanks a lot.
Thank you.
That's what our team member. We have designed this as a 2 days program, really, so that also burden and participants also not so much burden. So
Nobody-
team members designed this program, sir, beautifully.
Thank you, sir. This is the correct way, sir. This is the correct way. Even if it is possible, now I think instead of 5-day FDP, if it is 5-day means work like that.
Madam wants to speak something. Netra, want to speak something? Someone on the video, sorry, audio. Someone wants to give a valuable feedback for our next course of action with respect to a fruitful sessions. Any more to take the photo? I think some madam is speaking, but she has not unmuted her mic. I think the feedback link is shared in the message box. You can give the feedback, and after 2 days, patiently wait. We'll be giving the certificate. We'll be sending to your mail IDs. We'll be sending after 2 days certificates. The chat box, the forms are put. And thank you a lot for joining us for this 2 days faculty development program.